Hello, this is Nikhil Nanda, studying in SRIT College, pursuing first BTech in Mechanical Engineering. Today, subject name is Engineering Physics. My topic name is about interplanar spacing. Introduction. A matter in a solid state is arranged in a regular repeating pattern known as a crystal lattice. The lattice consists of planes of atoms stacked at fixed distances from each other. The distance between two adjacent parallel atomic planes is called interplanar spacing. It represented with the letter D. Understanding interplanar spacing is essential for studying X-ray diffraction, XRD, crystal structure, material identification, and defect analysis. Basic principle. When X-rays passes through a crystal, they interact with the irregularly spaced atomic planes. These planes act as reflecting surfaces that causes the X-rays to interfere, and constructive interference produces diffraction peaks that correspond to specific interplanar spacing. Basic principle is governed by Braggs law. Braggs law explains how X-rays are diffracted by the atomic planes in a crystalline material. When an X-ray beam strikes a crystal, the atoms arranged in parallel layers reflect the X-rays. These reflected X-rays interfere with each other. Constructive interference occurs only when the path difference between the rays is in integer multiple of the wavelength. This condition of constructive interference is expressed by Braggs law. Formula: n lambda is equals to 2d sin theta, and order of the diffraction 1, 2, 3, and the wavelength of the incident X-rays, interplanar spacing, distance between the atomic planes, and Braggs angle at which diffraction occurs. Types: 100 planes parallel to YZ direction. 110 planes cutting X and Y axis. 111 planes cutting all three axes, high index planes. 210 and 311, etc. Indexed by Miller indices H, K, L, which define orientation of planes. Working principle. The determination of interplanar spacing is based on the principle of X-ray diffraction. When a beam of X-rays strikes a crystalline material, the atomic planes within the crystal act as mirrors that reflect the incident X-rays. These reflections interfere with each other if the path difference between the reflected rays is an integral multiple of the wavelength. Constructive interference occurs, producing a detectable diffraction peak. This phenomenon is mathematically explained. 2d sin theta. This relates the wavelength of the X-rays, the angle of the interplanar spacing, by measuring the angle theta by the theta. The spacing at D between atomic planes to be calculated. This the working principle combines the interference and crystal symmetry to reveal the internal materials. Interplanar spacing, we can see that here. The formula: E by root h square by k square plus L square. Applications: used in X-ray diffraction, XRD, to determine crystal structure phase composition, lattice parameters, grain size and stress analysis used in semiconductors industries for wafer quality testing helps identify unknown materials and defects. It helps for identify unknown materials and defects essential for nanotechnology and materials engineering. Advantages and disadvantages. Advantages. The advantages of interplanar spacing are non-destructive method to analyze materials, helps identify crystalline phase accurately, provides detailed structural information, useful in metallurgy, chemistry, physics and engineering industries. Disadvantages: require specialized equipment, XRD emission. It works for crystalline materials, not amorphous. Interpretations may require expert knowledge. Only works for crystalline materials, not amorphous. Interpretation may require expert knowledge. Measurement accuracy depends on simple preparation. And the final one is conclusion. Interplanar spacing is fundamental concept in engineering physics that describes the distance between parallel atomic planes within a crystal lattice. It plays a crucial role in understanding the internal structure, arrangement, and behavior of crystalline materials. By applying Brock's law, the interplanar spacing can be accurately determined through X-ray diffraction, making it an essential tool for analyzing crystal properties, identifying materials, studying defects, and determining lattice parameters. Thank you.